Здравейте на всички, скъпи гости, благодаря, че отнехте от времето си тази сутрин, за да сте заедно с нас. Имаме едно прекрасно събитие тук, за което отдавна се подготвяхме и заедно с ПРОС в България направихме това възможно. Тъй като лектора ни, доктор Майкъл Ву, е американец, ще говорим на английски. Цялата тази презентация ще бъде на английски, затова следващите слова, които ще произнесе тук, стъпително слово, така да кажем, ще бъде само на английски. Още веднъж благодаря на всички, че дойдохте. Good morning, ladies and gentlemen. It is my immense pleasure to present to you our distinct colleague and friend, Dr. Майкъл Ву, who came here and basically journeyed across continents to come and see us and be with us today and tomorrow. For those I have yet to meet personally, my name is Alexander Iliev. I'm an associate professor at the Bulgarian Academy of Sciences at the Institute of Mathematics and Informatics. I'm delighted to introduce our guest of honor today. Dr. Wu and I first crossed paths at the University of California, Berkeley, amidst the challenging backdrop of the pandemic in 2021. There we have continued to educate and inspire our students. We still teach courses there. And back in 2021, it was during this period of time when we were called for a project titled Expert Seminar Series, AI and Machine Learning for Engineering, a program that still endures within the university offerings. In this venture, I undertook the role of lead instructor and moderator, as Michael characterized that aptly in his blog later. And Michael skillfully handled the module Introduction of AI Adoption and Maturity. Since those formative days, Dr. Wu and I forged a relationship built on mutual respect and deep appreciation for our respective areas of expertise, as he put it in his blog later as well. Our ongoing dialogue eventually crystallized in the opportunity to welcome him to the Bulgarian Academy in conjunction with the presence of his PROS colleagues here in Sofia, for whom I thank. Dr. Wu is a luminary who had many roles in his careers. Just to name a few: a triple major undergrad degree in applied math, physics, and molecular and cell biology. Later on, he took the PhD from UC Berkeley biophysics program, modeling the human brain. Chief AI strategist at PROS at Current, senior researcher fellow at École des Ponts Business School, advisor and a lecturer for UC Berkeley Extension AI programs, just like myself, where we met. Chief scientist at Lithium for a decade. He received a recognition as an influential leader by CRM magazine, and also the Department of Energy Fellow at the Los Alamos National Lab. A few words about PROS. PROS is hailing from the heart of Silicon Valley, is renowned for its innovative approach to enabling savvy digital era sales through predictive and prescriptive technologies, with PROS establishing an engineering hub in Sofia since 2017. The synergy for Dr. Wu's engagement as a guest lecturer for our academy was undeniable. Today's talk basically includes actually two short talks. It marks a significant occasion as we have the privilege of hosting Dr. Michael Woo, who will be conveying his insights through two pivotal lectures as part of today's event, titled Decoding General AI or Gen AI. The first lecture, Decoding Gen AI, the science behind the magic of ChatGPT, everybody's really crazy about ChatGPT these days, promises to demystify the complexity and unveil the science powering the controversial AI project. The second, Navigating the Limits of Gen AI and Business Decisions Beyond Productivity, will delve into the strategic integration of AI in business, transcending mere efficiency to drive decision-making processes. There will be a coffee break after that, in which we can facilitate a dynamic exchange among us, followed by the light lunch to continue our discussions informally. Before we commence, I extend my deepest gratitude to our Professor Boyvalenko, the director of our Institute of Mathematics and Informatics. Also to our scientific secretary, Krasimira Ivanova, who's sitting right in the back, for her effort in promoting this event. They both made this, reserving this whole, this venue possible. Moreover, I salute the PROS team in Sofia, particularly Emilia Rangilova and Stanislava Ponova for their meticulous planning that has brought us here and this event to fruition. I anticipate that each of you join us today driven by varied interest in the realm of Gen AI, a field that continues to captivate and revolutionize our lives in industries in unprecedented ways. Rest assured, Dr. Wu is poised to address the seminal topics within this domain. With no further ado, I will now yield the floor to Dr. Майкъл Ву. Please join me in extending a hearty welcome to our distinguished speaker. Let's welcome Dr. Wu with our warmest applause.
Thank you, everyone. I love The Mandalorian. This shiny suit is as close as I ever get to being Mandalorian. So as Alex had mentioned, we taught a class together at Berkeley, and it's always been my passion to teach. And today I will talk about this rather complex topic of generative AI, okay? So it's a very difficult topic, but I only have about 75 minutes for the first part of this. And, I planned this talk to be very interactive because I believe that, the best way for people to learn is when people are having fun. People are, people remember what they learn when they're having fun. So I'm going to make this very interactive so you can learn it well and retain it and truly understand how generative AI works. Okay, so I just want you to pay attention and have fun, and don't worry about taking notes. If you want the slide, you can connect with me on LinkedIn afterwards, and just send me a note, say that you are the Bulgarian Academy of Science lecturer, and I could give you a PDF version of this talk. Okay, so can I have your cooperation for this? Yes. Okay. So this is the way. Okay. So, hey, you guys watch Mandalorian? When you say in Mandalorian, do people watch Mandalorian here? Okay, so when I say this is the way, you're supposed to say this is the way, right? Okay, so let's try that again, okay? This is the way. Okay, good, excellent. Okay, so, with ChatGPT, no knowledge is essentially inaccessible. You could ask ChatGPT pretty much anything, right? You could even ask, ChatGPT or any other these generative AI tools such as Perplexity, how does ChatGPT work? And it's, it will tell you everything about you need to know. But the problem is that when you actually do this, it's like what Richard Feynman once famously said, that you can know the names of a bird in all the languages of the world, right? Or all the parts of the bird in all the languages of the world. But at the end, you know absolutely nothing about the bird, okay? So let's take a look at what the bird, and look what it's actually doing, right? That's what counts, okay? So that's what I mean by understanding. Knowing what it is doesn't give you any understanding at all. You have to know how it works, okay? So let's try to understand how generative AI actually work. Okay, so now to understand generative AI such as ChatGPT, you probably already know that ChatGPT is a large language model, right? Right, okay? So now to understand what a large language model is, you have to first understand what a language is, right? Okay, so a language is really nothing more than, the vocabulary plus the grammar, right? So that basically just means the words plus the syntax and in which those words are being used. That's a language, right? And everybody knows what a language is, right? So now, in machine learning, we call this a sequence of tokens, right? Word tokens. And the reason we call them token is because, a language is more than just a word, right? There's, punctuation, there's, abbreviation and all this, So for intents purpose, right, we could just think of, token and words as interchangeable for this audience. I think this is, in some other lecture, they do make a difference, but for this audience, let's treat them as just the same. Tokens and words are basically the same, okay? So now, if that's a language, right, then the language model is basically a probabilistic model that captures that sequential structure of the tokens, okay? Now, I've told you what it is. That's what it is. But you still have no idea how it works, right? That's exactly what Feynman says, right? You know what it is, but you still have no idea how it actually works. So let's take a look at what it's actually trying to do. So what it's trying to do is if you give me any sequence of tokens like S, can we predict the next word accurately? Okay, can you do that accurately, right? So that's actually denoted with this probability expression, probability of the word given that sequence, right? And that sequence can be any sequence, right? And the key to recognize is that, if you could do this, you would know everything about this language. If you could predict the next word given any sequence, you would know everything about this language, right? For example, if the sequence was, the water is filled with ribulose bisphosphate carboxylase oxygenase is very, what's the next word? What is that next word? Any biologists here? Plant biologists? No? Okay. See, if there's a vocabulary that you don't know, you cannot predict that next word, right? If you could predict that next word accurately for any sequence, you would know every single vocabulary in that language and every possible sentence construct, right? In fact, this is, ribulose bisphosphate carboxylate oxygenase is actually the enzyme that produces oxygen, in plant, okay? So if you know what that is, you'll be very refreshing or something like that, right? So, okay, so the key thing I want you to know is that if you could predict the next word accurately given any sequence, then you would know everything about this language, right? Every sentence construct, every vocabulary, all the grammars and so on, right? Okay, so let's play a little game here, okay? Let's play a game of do you know your English? So now if I give you a sequence, the sky is, what's the next word? Blue. Not today, right? What's today? Gray, okay? What else? I mean, blue and gray are not the only words. That's possible, right? Clear, right? I mean, there's many, many words, right? So excellent, right? So this is actually why you need a probabilistic model. Because there's so many different possibility of words that could go in there, right? If this was deterministic, right? If there's only one word that could go there, then you would not need a probabilistic model, right? Because this is so many different possibility, you need a probabilistic model to characterize the probability of each one of those possibility, okay? So now, how do you get that probability, right? The probability of the words given that sequence, right? You could approximate that by the number of times you see the word following the sequence divided by the number of the time you see the sequence, right? So basically, if it was blue, right, then you would see number of times you see the sky is blue divided by the number of times the sky is whatever, right? That's the odds. That's probability, right? That's approximate probability, right? So now where do you get that probability from? You get that from all digitized human writings, any digitized human writing. And that includes across the entire World Wide Web, right? Digitized books, scientific journals, which are already digitized, right? Most of them are digitized, and the entire Wikipedia too, right? Now you may think that the Wikipedia is pretty big, but it's actually very small compared to the rest of these data, the training data. Wikipedia here actually contribute only about 3%. 3%, okay? It's actually pretty small, okay? Now, if you look at that probability distribution, this, probability of the words given a sequence, and these are ranked by their probability, the highest probable word is blue, right? When I say the sky is, most of you say blue, right? That's probably the most likely, highest probable. Most of the time you see the sky is blue, right? But there are also many other words that's possible, right? So for example, you get like sky is clear, sky is cloudy, dark, gray, whatever, so all the words that's possible, right? So there's a probability for each one of those probability, and that's why it's called a probabilistic model, okay? Now, if you extend this out to all the commonly used English word, it's about 30,000 words. Okay, 30,000 words here. And because, you have these scientific journals, so you also have all these scientific terms, medical terms, legal terms, all these highly specialized languages, right? And that's probably extends out to about 2 million, a little less than 2 million. So the entire lexicon of English is about 2 million tokens, okay? So now, so most of these words here have probability of 0 because you never see people use those words to describe the sky. For example, you never see people say the sky is delicious, right? Never, right? Okay? That's why the word delicious have probability of 0. Okay? All right? Now, what happens if I give you a little bit more context? If I give you extra context, for example, the sun just set, the sky is, now what's the word? What's the next word? Red? Dark? Dark? Well, sun just set, maybe not so dark yet, but okay, but red, what else? I mean, there's many words, right? Again, many words are possible, okay? So, basically, you do this same thing again, right? You see the number of times you see the sun is set, the sky is whatever that word is, divided by the number of sun is just set, the sky is whatever, right? So, and then if you do this calculation from all this training data, you will find that, the previously highly probable word get pushed down, okay? They get pushed down, okay? Because when the sun is just set, right, the sky is probably never blue, right? It could be dark, right? Could be clear, could be cloudy, right? It's just all possible, but they get pushed down, right? It's blue probably get pushed down all the way down to 0, okay? Because after the sun sets, the sky is almost never blue, okay? So now, but other words, they get boosted, okay? They get boosted. So, and this boosting is done by what we call the attention mechanism. The attention mechanism is like human attention is like a spotlight. You focus on something, okay? You focus on some word. So what are some of the words that you focus on to give this probability a boost when you see the sun is just set and the sky is, right? Yeah, you for example, like these words, right? These words such as, blazing, golden, spectacular, beautiful, orange, red, right? All these words that you start to focusing on those words because you see sunset, right? Okay? So you give those words a high probability so they get boosted up, okay? So now what it does to this distribution is that it makes this distribution very sharp. Make this distribution sharper, okay? Much more narrow, okay? Now, if I give you even a little bit more context, for example, it's raining hard, the sun just set, the sky is, now what's the next word? Dark, right? Gloomy, terrible, yucky, right? All these other words are possible, right? So again, same mechanism again, right? When you see about the raining hard, right? Your attention mechanism focuses you on those words, right? And it boosts those words up, right? And then the other words get pushed down, right? So now the probability distribution get even sharper, okay? So what does that mean? What that means is that the more context you provide, the better it is this model is to stay on topic. It's able to stay on topic really well, okay? So now, this probability model, right, is actually trained with all this data. This data here consists of 500 billion tokens. 500 billion words, right? That's a lot of words. That's a lot of tokens, right? But compared to infinity, it's nothing, right? I mean, I know there's some mathematicians here, right? Infinity is actually a very powerful concept, right? No matter how big you get, compared to infinity is always nothing, right? So, all right? So what you have here is really not the true distribution, right? It's actually only approximate. So this is really just an empirical probability distribution of the words given that sequence, right? Now this distribution is a little bit hard to visualize, so I'm not gonna, most people here are may not have a statistics or probability background, right? So I don't want you to make you visualize this, but all of you probably have seen Gaussian distribution sometime in your life, right? Sometimes it's called a normal distribution. You've seen that sometime in your life, right? Right? Okay. So this is an empirical Gaussian distribution. So what does the true Gaussian distribution look like? It's just a smoothed out version, right? Kind of like this, like that, right? Now the key thing to recognize is that, you know, there are regions in the empirical distribution that have zero probability, right? P equals 0 in blue. The blue is 0 right here. But that doesn't mean the true distribution, the true Gaussian distribution is 0 probability here, right? Okay, in fact, this true Gaussian distribution is never 0 anywhere, right? It's never until you get to positive infinity and negative infinity, right? It's actually never 0 anywhere, okay? So now, the key thing to recognize is that this is exactly like the example of the sky is delicious, right? You've never seen it. You've never seen it in reality, right? Nobody's ever said the sky is delicious. So empirically, from the data, you've never seen it. But that doesn't mean that you cannot say the sky is delicious or it's not allowed, right? If you actually provide this enough context, for example, you said I'm writing a children's book where about this candy land, this fantasy candy land, where the clouds are made of cotton candies, like this, right? Now, it's definitely possible to say the sky is delicious, right? Okay, because when you give it enough context in your prompt, right? Say, I'm writing a children's book about Candyland, and the clouds are made of cotton candies, right? And cotton candy, you know, all of a sudden your attention mechanisms start to boosting those words that's associated with cotton candy, which includes sweet, delicious, all those stuff, right? All the other words. So it's possible to say this sky is delicious, okay? So now, this is actually very important, okay? The fact that this true distribution, the pink one, okay, is actually never 0, means that any word, anything is possible under this distribution, anything is possible, okay? And this is actually what gives the generative AI the ability to create content that never existed before, right? Empirically, 0, never existed before, but you can still create it, okay? That's actually why we call this generative AI. It's generating content, okay? All right, now this is actually very important, okay? So this is the way. All right, come on, you guys are a little slow here. Is that the light too dim here? All right, so this is the way. This is actually how generative AI generate novel content that never existed before, okay? It's because the word probability that you sample from is never 0 anywhere, okay? Everything is possible, okay? All right, so we have seen that you get this empirical probability distribution from all this training data. The problem is, which is, you know, think of it as an empirical Gaussian distribution, right? Okay, think of it like that. It's not the Gaussian distribution, but it's hard to visualize this, okay? So, okay, now how do you get to this true distribution? Remember what I said. This probability distribution of the words given any sequence, that is the language model. Remember I told you that from the beginning? That is the language model. So how do you get this from this? I know how to get this from all this, but how do I get this one? So this is where transformer comes in and help. You know, transformer, well, it's a robot, but it's also a neural network architecture, okay? It's a neural network architecture that's pretty complicated. You know, it's actually created by a group at Google, okay? So they published a paper called Attention is All You Need. And all you need to know is really that, about transformer is that it actually encodes, it actually is an implementation of the attention mechanism that we talk about, okay? So in fact, if you actually look into this paper, right, attention, it's this spotlight, that boosts the probability. This, if you look at this, it's actually, it's an encoder, decoder, neural network architecture called the transformer, right? It's published in 2017. So it actually hasn't been published that long, okay? So this is actually, something that is within the last 10 years, So that's all you need to know, okay? That's all you need to know. If you are technical, you are data scientist, you want to know more about this, you can talk to me afterwards. But for this audience, let's, basically the transformer is just a mechanism for you to encode and implement this attention mechanism, okay? So now, at the end, what comes out of this transformer is some kind of probability. And that probability is precisely this probability distribution given any sequence. So now you actually have the language model here. That's it right there, okay? Now, the thing about having the true distribution of anything, what's the advantage of having a true distribution of anything? Is that you could sample from it, right? You could start, if you have a true Gaussian distribution and you sample from the Gaussian distribution, what do you get? You get a random number, right? You get a random number. So if you get a probability distribution, the true distribution of over all the words given any sequence, and you sample from that, what do you get? You get a word, right? You get a not really random word because this probability distribution is not random, right? So it actually give you the highest probability where you're going to sample if the sequence is the sky is, right? The word that you sample most frequently is probably blue. You're going to get blue, 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 and gray. And then most of the time you're going to get blue, 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 and then some gloomy, yucky, dirty, whatever, some other words, right? So, okay, so now you sample from this distribution, you're going to get a word, right? You sample from that, you get a word. Basically, you could concatenate that word with the sequence, right? You can make a sequence that's a new sequence that's one token longer than the previous one, okay? And basically, you could put this longer sequence back into this transformer again, and you could do this again, and again, and again, and again. And that's actually how ChatGPT generates word after word after word after word and create sentences. And generate sentence after sentence after sentence, create paragraph, and create essays, create novels. That's how it's done, okay? That's all it's doing. So basically, this box right here, this decoder portion of the transformer architecture, this is the GPT model. That is GPT. Okay, so GPT actually now you know it stands for Generative Pre-trained Transformer. It's a large language model. But now you know it's really nothing more than a random number generator, right? From a distribution over all the words given any sequence, given any sequence, right? And it's trained with all the human written text that's digitized, right, using this transformer architecture. That's all there is, right? I mean, are you surprised to see what this is? This is what the large language model is. ChatGPT sounds very smart, but this doesn't sound very smart, right? In fact, this sounds kind of stupid, right? Sounds kind of dumb, right? Doesn't sound very intelligent, right? Okay, so keep in mind that, you may say that, okay, wow, that's just a GPT model, right? That's the base model. It's not really ChatGPT yet, right? Yeah, but it's we know that when we get here, you get GPT, right? How do you get to ChatGPT? ChatGPT, basically when you have this, when you have the language model, you have a way to do plausible continuation of text, right? You give me any text, any sequence, I will be able to continue it. Okay, I'll be able to continue. The problem is that plausible continuation doesn't always mean it's a good response. Right? For example, you could say the user may say explain how cost-based pricing in B2B work, whatever that may be, right? And a plausible continuation is the LLM could say explain how value-based pricing works in B2C. It's definitely possible, right? In fact, these are probably exam questions for some, economic, this one question after another, it's very plausible, right? Definitely plausible, but it's not answering the question, right? So basically, the the people at OpenAI have to do this supervised transfer learning to fine-tune the model to follow instructions and provide answer to your question rather than just providing plausible continuation of text. Okay? So when you do this, basically now ChatGPT can follow instruction. It can actually follow what you tell it to do or answer your question that you're actually asking. Okay? Now, being able to answer questions it's also, doesn't mean that it's a good kind of an open-ended dialogue, right? ChatGPT, if you play with ChatGPT, it's actually very chatty. It's very, it's like to talk to you. It's like to sometimes very verbose, right? So people like that, right? People like that chattiness, right? But being able to answer questions doesn't always means that you can have a good dialogue, right? Sometimes actually, by answering your question too concisely, you have no more conversation. Right? Sometimes you just have some people ask you a question and then you just answer yes, no, and then that's it. And then, there's no conversation, no opportunity for you to have a communication, right? So now they use OpenAI, basically have to do another step. They basically say, they have to use this reinforcement learning with human in the loop to rank what is a good dialogue, okay? What is a good dialogue? And that's actually not an easy task. It's actually very difficult because, they use reinforcement learning. If you know about reinforcement learning, is that you use this language model to generate response, right? And then you have human rank whether this is a good dialogue or not. Okay, so this is human in the loop ranking. But the problem with this is that humans are not very consistent. Right? So, scoring a good dialogue is kind of nebulous. It's very hard to score a good dialogue, right? And humans are actually not consistent among themselves, right? Some people say, okay, this is a very good dialogue to me, but then the other person say, no, that's actually not so good dialogue, right? But even if the other person agrees a good dialogue, he may not agree on the score, right? I may say this is a very good dialogue. It's 90%. If I give it 1 out of 100 score, he may say it's a good dialogue, but I think it's only 65%, right? So it's actually not very easy to do this. So what OpenAI do is that they have to calibrate across all the humans, right? So what they do is that they basically generated several responses and then have human basically order them, right? Basically rank them, okay, C is better than A is better than D is better than B, right? So now you get a pair, many pairs of training set, right? That you can actually train a supervised reward function, right? So you have all these humans train this scoring function, right? So this is essentially AI that tells you whether you have a good dialogue or not. Okay. Now if you have this AI that could score how good a dialogue is, basically give you a score from 0 to 100 or something like that, right? So how good of a dialogue is being generated, right? Then you could just do this reinforcement learning, and this GPT becomes better and better at having a good dialogue. Okay. So now you have basically ChatGPT that you see today. It can talk to you, have a good dialogue, even have, make jokes or do all kinds of stuff with you, write poems or whatever you want, right? Okay? But the key thing to recognize is that ChatGPT, still has no knowledge of the real world. It still have no knowledge see all the training that we gone through to train ChatGPT. There's nowhere in the training that teach him how the physics of the world actually works, right? It doesn't know that if I pick this up and drop it, it's gonna fall, right? Other than the fact that other people written about it, right? Even have no idea about how this world works, right? So in fact, there's this problem called generative AI, right? So by generative AI are by definition and by construction hallucinatory. Okay? They're hallucinatory. People worry about hallucination, but that is actually a fundamental property of generative AI. Okay? Because you have no idea what's possible and what's not possible. It just depending on what context you give it, right? Even though in real world, you never see clouds made of cotton candy, right? But if you give it the context in your prompt to tell it to write, about, cotton candy, how about this fantasy land where the clouds are made of cotton candy, you will write a bunch of things and you would think it's actually real, okay? So, okay, in fact, this hallucination is such a big problem that, lawyers have used ChatGPT to create a legal briefing, and ChatGPT actually cited cases that doesn't exist, okay? So, and these are lawyers, you know, they're not like stupid people, they're actually pretty smart people, right? Is able to convince this lawyer to deliver this in front of a judge, okay? And guess what? You know, he of course get, you know, sanctioned, he get fined, and you know, actually I think the loss of his reputation probably cost him a lot more than the fine, okay? So, okay, so hallucination, real problem, okay? Now, the question is that a feature or is that a bug? How many people think it's a feature? How many people think it's a bug? Okay? Well, it depends on what you use it for, right? It depends on what you use it for, right? If you are in, say, in a design or creative industry, right, then it's a wonderful feature, right? You wanted to write story that no one had written before. You wanted to design fashion that no one has designed before. You wanted to create music that no one has created before, right? But if you have a fact-based application, then it looks like a bug, right? It looks like a problem. Because it could create things that are so realistic and he's going to sound so confident that you can't tell if it's actually real or not, okay? You cannot tell because, you know, the generative AI is going to give you something very convincing, okay? Okay, now the question is, does that mean you cannot use generative AI in a fact-based application? Does it mean you cannot use it? Okay? Now, if you go to Google today or go to Bing search today, right, you type in some question, it looks like it's generating a bunch of answers for you there too, right? Okay, so how do they actually do that? Okay, so the key thing to recognize is that if you want to use generative AI in a fact-based application, you need something called grounding. Okay, you need grounding. So what grounding means, grounding is actually just any method, any technique that uses to reduce hallucination, to make it more realistic, you ground it, okay, essentially, to make it, not hallucinate as much, okay? So what that, in terms of this distribution, what it really is that, you know, when you look at this distribution, like the real distribution of Gaussian distribution and the empirical Gaussian distribution, right? When grounding just means that when there is no data empirically, like such as right here or out here or in this region or out here, right? Don't make things up. I don't want you to make things up, okay? So now, one very easy way to accomplish this is basically you could say, look at anywhere that the blue is 0 and set the pink to 0, right? In fact, you could just multiply them together, right? And then normalize it again, right? Almost, you could, right? So, but think about what would happen there. When you actually make this true distribution 0, anywhere this blue is 0, what will happen? Basically, you can no longer generate anything that never existed before. Right? You basically kill generative AI, okay? So if you completely get rid of hallucination, you don't have a generative AI anymore. Because it's no longer able to generate anything that did not exist previously, okay? So that's why I say hallucination is actually a fundamental property of all generative AI, okay? By construction and by definition, it will hallucinate, okay? So how do I make it work in a fact-based application, right? Traditionally, how do you work with a fact-based application? What's a tool that most people use when you want to work with fact? It's a search engine, right? You find it, right? So this is basically you use conventional information retrieval, such as a search engine. Okay? So the key thing to recognize is that even though the large language model cannot be used in a fact-based, should not be used in a fact-based application because of hallucination, doesn't mean you cannot use it. All right? You just have to use it together with something else. You need something else to help it, to reduce hallucination, okay? And you do that by, for example, working with such as a search engine. So what you do is that like, you use your search engine to search the facts, right? And then you recover all the facts, right? And once you recover the fact, you can actually give it to ChatGPT and have it summarize it before you give it to the user. And that's what you're seeing when you go to Google and Bing search today. All the answers it's generating, the large language model is not generating those answers. It's the search engine that's actually searching all the answer and give it to a ChatGPT and tell it to summarize it for you. That's all it's actually doing there, okay? And so when you actually, what happens when your search engine doesn't find anything, right? When you cannot find anything, you just tell the user, I don't know, right? Don't give it to the ChatGPT, right? If you give it to ChatGPT, it's going to make things up, right? So, right? So this is, you are coupling the large language model, this generative AI, together with a search engine, right? Or a standard conventional information retrieval tool, right? So that's why this mechanism is called retrieval augmented generation, right? It's called using information retrieval to augment your generative AI, right? It's called RAG, retrieval augmented generation, okay? So now, there's basically two ways you can work with large language model, right? There's one way is you do model fine-tuning, right? That's actually, there's some advantage to that, right? The advantage is that, knowledge is encoded into the model parameter, into a neural network, deep inside your transformer neural network architecture. Now, you're actually changing the model parameter there, right? Basically, what that means is you could teach anything. You could, if there's an alien language from another planet, right? You could teach it to speak that language if you want, okay? If you have the data, right? But the problem is that it's actually very, very expensive, okay? It costs, OpenAI $63 million just to buy the hardware to train, GPT 3.5 to GPT 4. And it took them like almost 4 months, 100 days, okay? Just the hardware. They're not even counting all the, engineer and data scientists, all their salaries and everything goes into that, right? So that's just the hardware, very expensive, right? And the problem, another problem is that once you have new data, when you have another language or from another planet, right? You need to train it again, right? You have to retrain it. And so it's actually very hard to iterate, very hard, very, I would say, not ideal when you want to go to market fast, right? So the other way is basically using this retrieval augmented generation. It's basically just prompting. I just created a new prompt, right, to this large language model, okay? So the advantage is that there's no upfront costs, right? There's no retraining for new data, right? Easily, you can even swap out language models, right? You can actually test out, how well GPT works, or how well does Llama works, or any other language model you want, okay? So it's much faster to do it this way, okay? So do people understand how this RAG work, this information retrieval, okay? Basically, for example, so Alex, what question do you want to ask ChatGPT this morning? Okay, what would be the market price of a stock that you want this morning, right? So now, what happens if you go to OpenAI, ChatGPT, and you ask a question? What would it tell you? Well, I mean, even if you can, right? It will basically tell you my training stops in 2023, I think April, right? Depending on that's the latest version, right? If you use the free version, it's even earlier, right? September 2021, something like that, right? So my training stops in September 2021. I don't know anything after that, right? Okay, but ChatGPT actually really doesn't need to know that. You can use this retrieval augmented generation to get the answer, right? Basically, you can actually, what's the stock, say like Pro stock, okay? Pro stock, okay? So what's a Pro stock price this morning, right? You could actually go to your Google, or your Bing, whatever search engine you want, and you will search that, and you will find the price for the Pro stock this morning, right? And then you basically give all that information to ChatGPT, and then ask ChatGPT to answer your question based on this information that I found. Okay? So that's just prompting. You just make the prompt. Your prompt is just like one simple question, right? What's the stock price for Pros this morning, right? But now You change the prompt. You basically engineer a new prompt. Your new prompt actually includes all the text, all the pages that talk about the pro stock price this morning, okay? How, at this minute, this time, right? All this, give it to, so that all those texts, all this information get added to the prompt. This new prompt is given to ChatGPT, and then ChatGPT can actually answer your question based on those prompts, right? It doesn't have to know what the stock price is this morning, okay? Right? Same thing. For example, you can actually ask, what happened at the Bulgarian Academy of Science today at 9 a.m., right? If you ask that question, it's not going to know, right? He said, my training stops in 2021. I can't answer that question. But if you go to Google and search, what happened at 9 a.m. at Bulgarian Academy of Science, it will show you, Michael Woo coming from giving this lecture and so on and so on. You find all those texts, right? All those texts will be given to the ChatGPT in conjunction with your question. So you augmented this, you basically create a new prompt that's much longer, okay? And then have ChatGPT answer that prompt, okay? Respond to that prompt, okay? So that's actually the retrieval augmented generation, right? You're using this search result to augment the generation process, right? So the downside of doing, so there's a lot of good things about this, right? But the downside is that you have a limited context length, right? You can't search the entire web and give it to it, right? It doesn't have that much memory, okay? So if you use GPT-4, it's 128K token, which is actually quite a lot, okay? But when you're actually doing this RAG approach, right? So 128K, in fact, few thousand is probably more than enough if you have a chatbot type of application. Right? If you just wanted to chat and talk to ChatGPT, it could remember, a lot of things, right? I mean, few thousand tokens is actually a lot, right? Because when you chat, you don't usually type in, pages and pages of text, right? But when you're using this RAG approach, right, you may find a document that contains hundreds of pages, right? So, 128K may not be that long compared to, for this RAG kind of application. So, okay, so it has a limited memory, it has a limited context length, okay? And also your knowledge accuracy kind of depends on your information retrieval, depending on your search result. Okay, if your information retrieval, your search engine is giving you garbage, right? Then basically the large language model is going to return garbage. Yeah, right? It's basically summarizing garbage, it's still going to give you garbage, right? So, okay? Okay, so this is the way. Okay, so this is actually how to use a large language model or a generative AI in a fact-based application. Is using this retrieval augmented generation, okay? All right, just basically prompt engineering. You just engineer new prompts, longer prompts, right? That contains essentially results that you find using search engine, okay? Okay, so LLM, this large language model, it's a foundation model, right? That means that they're pre-trained with a broad range of data, with the wide range of applications. So the way that I like to think about this, right? The way that you should think about this large language model is really, the best way to think about it is it's actually a person, okay? Think of it as actually a person, a language guru with a broad general knowledge, right? Think of ChatGPT as a colleague. He can read some of this property, this skill of this person, this colleague is that he can read super fast, understand any language, right? He's actually very forgetful, okay? Forgetful meaning that, have a small working memory. It's a limited context length, right? So whatever you give it, provide, right? Let's say, if you use GPT 3.5, the context length is about 4,000 words. Anything beyond that 4,000 words, it's going to forget, okay? So, but when you're actually chatting with it, it looks like you can remember forever, right? Because you don't chat using 4,000 words all the time, right? You chat with, hundreds of words, right? Most of the time, I mean, even if you talk for a long time, it's still, thousands of words. It's actually quite a lot, right? So it's forgetful in terms of, not in time, right? So it's forgetful in the fact that its working memory is limited. Right? If you give it more, if you make it read a novel that's say 5,000 tokens, 5,000 words long, right? Basically the first 1,000 words is going to forget, okay? If you only has 4,000 tokens, right, of memory. Even if you just read it now, the first 1,000 it's going to forget, right? But if you chat with it, say, using a few hundred words, right? And you wait like 10 years or 20 years, right? And then talk to it again, it's going to remember it as if it just talked to you yesterday. The memory doesn't fade with time. The memory fades with the length and the content amount, okay? So it's forgetful in that respect, okay? Not human actually forget because of time, because of complexity, right? So this person actually forget because it's actually beyond the working memory, okay? So, so it has broad knowledge. It knows pretty much everything, all the knowledge is out there, right? But nothing specific, right? Not to a specific person, not to a specific company, specific customer, or specific, anything that's specific, right? It's very, very imaginative. It makes things up all the time, okay? But it's overconfident, okay? Even when it makes things up, it's going to say it in such a way that it's as if it's real. So you can't tell, you can't really, tell if it's actually making things up or not, okay? So if you have a colleague who has this skill, how would you work with this colleague, right? The best way is to make sure he reads everything before he answers a question, right? And that's what retrieval augmented generation does, right? Read this and then answer this question, right? And what you wanted to read is actually found by your search engine, okay? All right. Okay, so today, if you actually go to Perplexity or so BART is actually renamed to Gemini now. If we go to Bing search, Bing actually uses the OpenAI ChatGPT model, right? All of those, these are essentially a big RAG. It's a massive, big retrieval augmented generation. It's using search engine, right? Google and Bing is using its plain old search, okay? And then give the result to ChatGPT or the large language model and then to summarize it. That's all, okay? All right. Okay, so hopefully you understand a little bit more about ChatGPT and how it actually works, right? You get a hang of it? Get the hang of it, okay? Good, excellent. So now let's go a little bit further beyond, okay? Let's go a little bit beyond ChatGPT. Now there's lots of, I would say, these generic generative AI, right? That work with text, visual data, audio data, right? Which include images, video, and speeches and music. Right? So if you look at the text domain, right? If you look at only the language domain, there's actually lots and lots of language models out there, right? GPT is actually not the only one. In fact, it's not only not even the first one out there. So BERT right here, the bidirectional encoding, transformer here is actually invented by Google, the same group who invented the transformer architecture. So that's actually the first one out there, the language model, right? There's actually subsequently a lot more created out there. And every one of these models can actually help you with a lot of different applications. It can help you with general writing, summarizing notes, okay? Right? Summarizing and take notes, compare, contrast, documents, right? Legal professions love that. Basically they have a big pile of legal document here and here. What's new? What's different, right? So, and it's not just doing the exact match. It actually knows that, when you're actually using different words, different way to describe something, it's actually the same thing, right? So it actually knows that, okay? Compare and contrast, content creation, actually answer questions, and because it knows all the languages of the world, so you could do real-time translation too. So in the future, I could be speaking English here, and all of you will be hearing Bulgarian. So, okay? It's possible, right? Okay, so from all this, basically many startups actually created just taking a few of these applications and just perfect their delivery, right? So many startups are created. Now, if you actually look at code, right? Coding is actually very interesting. There's actually many like codex type of model, right? But if you think about it, code is just another language, right? It's a language that we humans use to talk to machines. That's all, right? So if this large language model can translate from English to Bulgarian, it can translate from English to Python, C++, Java, or anything you want, right? It's just another language. It's a language that we use to talk to machines, that's all, right? Okay, so Yeah, so there's actually a lot of interest in visual type of generative AI, right? DALL-E. I think many people actually have played with this. You could use it to generate images, generate videos, right? Even generate speeches and musics and so on, right? So in the future, there will even be, I would say, some of these specialized generative AI, okay, that are knows a little bit more beyond this generic data type, okay? So the first one that came out is actually in the gaming domain. These generative AI can actually create realistic 3D world, okay? It knows the perspective, right? It knows occlusion, right? It knows that when I walk behind this podium, my body didn't just disappear. It knows that my body is still here. I'm just behind it. It's occluded by this podium, okay? So this human MDM, actually, I think it's called human motion diffusion model, something like that, okay? It knows what's a realistic human motion. It knows that I cannot bend my joint the other way because I'm not an alien, okay? So it has to know all that, right? So in the biotech world, you can already generate molecules or drug, for candidates for drugs. I want a molecule with certain molecular weight that have to have a binding site for adenine residuals of a certain protein, right? I could tell it what I want, and then you would generate molecules for me, novel molecules that never existed before. Some of them you may thought of, some of them you may not, okay? And people can actually just go and evaluate those molecule to see whether they actually possess the property that they claim to do before they actually synthesize and test them. And you could generate thousands, tens of thousands, hundreds of thousands of these and test them out, evaluate them before you're actually making them, right? Very, very, I would say, huge productivity gain, right? In terms of the work of a molecular biologist, right? So in the future, I would say that, there's a lot more of these models to come, right? There may be even a model that could, where I could describe that, I want to design a wing that has a certain drag coefficient and that provides certain lift, and it cannot be more than 50 meters long. Or it would generate a design for that wing, okay? So lots of things become possible in the future, okay? And a lot more use cases to come, and probably many, many more startups will be created from that, okay? So now, whenever there's a new technology that's, highly disruptive, such as generative AI, you get this problem. People have a new hammer, they see everything as a nail. They want to hit everything as with it, okay. So ever since ChatGPT was launched, lots of people have come up to me and say, can you use ChatGPT for this? Can you use it for that? So let's take a look at some of these cases. There's actually some good, some bad, and some ugly use cases. A lot of those actually will work, but they may not be the best use cases, okay? So let's take a quickly look at some of these, right? So one is like, can you use ChatGPT to help you discover market trends? Now probably you can, right? Because ChatGPT, training stopped in 2021, September of 2021, and it doesn't know anything after that, right? But you can actually use it together with search engine, but then the search engine is actually discovering the market trend, right? The language model is just summarizing it for you. That's all, right? So can you do automated SEO keyword research? Anybody here from marketing? Some are here from marketing, right? So you know what keyword research involves, right? Do you think you can use that for keyword research? So GPT can certainly give you a list of keywords, but you would have no idea how I perform. You still need to test them, okay? You could use it to help you start doing your keyword research, but you can't automate it completely, okay? Because ChatGPT is actually not trained with the results of what people click on the search engine. Those data are not used to train, the GPT model, right? It would have no idea how well performed, which actually link people actually clicked on, okay? And that's actually what's needed for keyword research, right? So this is actually a pros kind of a use case. So if people ask me, like, can you use English to kind of describe a pricing method, right? So these pricing methods, think of them as a kind of an Excel formula, right? How do you do pricing and, in what kind of context? So the things are like, it could work, but probably not the best use case, right? I mean, imagine you have an Excel formula very complex, 6 layers of parentheses, right? How are you going to describe that in English? Good luck, right? So, but on the other hand, if you have a very complex formula, right, you could definitely ask ChatGPT, explain to me what this formula is actually doing. That's probably a better use case there, okay? So this one actually is for my cousin. So my cousin is actually, she's the IT director of a big company. So she often has to write employee performance reports. So now she just actually writes, in the Excel, kind of basically write some bullet points, and then cut and paste in ChatGPT, and ChatGPT actually write a nicely beautiful formatted report to deliver to his employee, her report. Yeah? Not very scalable, works, right? But probably not the best use case, but it does work. It does help, right? So how about this one? Explaining complex data and charts. Scientific visualization exists for a reason. It's because language is actually fairly bad at describing data, right? So you can certainly use it to highlight certain aspects of a chart or something, or a graph, right? But to replace it completely, that would be kind of a mistake. Because if you have a graph, with a lot of data points, how are you going to summarize that? At x equals like 1.5, its value is what? I mean, you're going to do that for 100 times? If you have 100 data point, you're going to do that for, what if you have 1,000 data point or 10,000 data point, right? That would be crazy, right? So this one is actually rather interesting. Enterprise knowledge base. A lot of people wanted to use it to answer questions for employees, right? Internally for employees. So I actually worked with quite a few companies on this. So some company actually made it work really well, but some company doesn't work at all, okay? And the difference is the quality of the data, okay? The company that actually tag the data well, okay, it will work amazing, okay? But company who have poor data management, right, or knowledge management practice, right, this generative AI is not going to fix your bad data problem, right? Because garbage going into your generative AI, you're going to get garbage out, okay? You're going to get wrong answer, and the worst is that actually you can't tell if it's actually bad or not because it's so confident, this generative AI, okay? So, okay, so again, so this is the way. Actually, this is actually, in fact, not the way. This is actually the way how not to use generative AI, right? These are the bad use cases. So what would be a good use case of generative AI? A good use case of generative AI is use cases that essentially leverage the generative nature of this generative AI, right? So what does that mean? Leveraging the generative nature. That means basically things that are not prescriptable, right? Not pre-programmable. They're created at the moment, right? You cannot pre-program it, right? If you can pre-program it and prescript it, you should just pre-program it because it's actually a lot cheaper and a lot more efficient that way, right? And you have lots of good things, a lot less environmental impact and so on, right? But if you can't do all this, right, then you're leveraging the true generative nature of it, right? So what are some of these? If you remember this picture, this diagram, all the use cases that I talk about at the bottom here are precisely those that are good use cases, right? If you wanted to do question and answer, right? I can't prescribe that because I don't know what question you can ask. It's not like I'm going to answer like 1 out of 1,000 questions. If I'm going to answer 1 out of 1,000 questions, I could prescribe the answer to all those 1,000 questions. I'm done, right? Because the possibility is so big. Real-time translation, right? I don't know what you want me to translate. So I had to be created at the moment, right? You can't pre-program these, right? Those are leveraging the true generative nature of this generative AI. Those would be good use cases, okay? All right. So let's take a look at one use cases that's actually rather interesting is coding, generating code. Because today, generative AI could write code, can actually like an engineer. So one of the really interesting use case, I would say like not a use case, but one of the really interesting thing about this code generation use case is the fact that there's a lot of copyright issue involved. Okay, when you write a set of code with generative AI, who holds the copyright? Okay? Actually, nobody knows the answer right now, okay? Because this is actually the case of this woman here. So she goes by Chris, Casanova, she actually uses Midjourney. So Midjourney is a generative AI that generates images. Okay, you describe, okay, I want a picture of a lecture hall with, people sitting there with a, a guy wearing this hat, wearing a shiny shoe, giving a lecture. It's going to generate this picture. Okay, so you describe an image. So she actually uses Midjourney to create an entire graphic novel, almost like a comic book. And she wanted to copyright this. And guess what the US court says? You can't copyright those because you did not create any of those images. Okay? They said that you can copyright all the prompts that you use to create those images because you created those prompts. You wrote those prompts. But you did not create all the images. Okay? The images are created by generative AI that you don't even know how it works. So you can't copyright those. Okay? So that's the same thing with code, right? When you're actually writing code, you cannot copyright those code, right? So this is why even in my own company, at Pros, we actually tell our data scientists and engineer, if it's actually core IP, right, that you care about copyright, don't use it. Don't use generative AI to help you write it, right? If you wanted to, if it's something that you don't care, people steal it or reverse engineer it, go ahead. Write it all you want, right? So what are some of the cases that, why would you write code that you don't care people stealing it, right? There's actually a lot of cases. For example, like in this case, you can ask, for example, using natural language, any question against a database, right? And then basically you would generate a SQL and execute that SQL against the database to get the answer that you want, right? That's an interesting one. So basically, as part of the prompt, right, I will have to engineer the prompt to include things such as database schema, the data dictionary, the column definition, and all that stuff, right? So you know what the database is about. And then I can ask them a question, right? For example, I could ask the question like, what is the total margin lift for my French customers last quarter? Okay? It's going to generate a SQL. An actual SQL, okay? These are code that used to be written by a data analyst or something like that, right? And you can execute that code against a database, right? And it's going to come back with some answer, say 5.78 million euro. Okay? Now, this is really interesting because, whenever you work with generative AI, it's always advisable to have some kind of guardrail, because there's so much we don't know about it, okay? So for example, like, you may want to make sure that there's only read-only permission. You don't want people to accidentally, overwritten some data, right? You have to respect access permission, right? Some people may not have access to this information, right? So all those are still hold, right? So you always wanted to make sure that you have some kind of guardrail, right, when you're using generative AI. But the other thing is that, like, when you have something like this, think about, the value and adoption of this tool. How are people going to use this, right? The reason I ask, this question against the database is because I don't know what the answer is. But if you executed this SQL against the database and give me this answer, how would I know it's accurate? How would you know? You cannot know, right? How would you know? The only way for you to know is you will have to go and write the SQL yourself against the database and check it to see if it actually come up exactly the same. But if you have to do that, why ask the generative AI anyway? Right? There's no reason to ask it in the first place if you're going to check it every time, right? So basically, if you actually generate this answer, it has to be able to explain this aggregate result. Why am I getting $5.78 million euro, right? Why is that the answer, right? The problem is that, like, human language is actually very imprecise, okay? So you may think you are very precise. I tell it to get the total margin lift for my French customer last quarter, right? But machine can interpret that hundreds of different ways, okay? Say like French customer. Do you mean like customer inside the country France? Or do you mean French-speaking customers? Do you care about French colonies? There's a whole bunch of ways for a machine to interpret that, right? So you have to explain, okay, these are the customer that I get, and these are the margin lift for each one of the customer, and then when I sum those up, it becomes 5.78 million euro, right? But you may actually go say, oh, no, this, I want you to exclude this one because these are not customers inside the French, inside France, the country, okay? So you may correct it that way. So you have to be able to, step through this calculation, in order to truly get value from this, right? So the key thing still I want to say is that like without trust, there's no value, right? Because without trust, you have to check it every time. If you check it every time, there's no use asking it in the first place, right? Okay. All right. So today, ChatGPT, you have plugins, such as co-interpreters. So co-interpreters actually rename again to something called advanced data analysis, right? So it can actually write code for you. You can actually describe, I want my code I want to generate create a code with a website that does this, all that. Describe it, and then you could just translate that code. So now if you could translate English to any programming language you want, you can pretty much do anything you want, right? I mean, if you are a mathematician, right, computer science, you will know that there are some, thing that's not possible with code. But for most of the business application, it's actually possible, right? For most of the business application, it's actually, if you could, translate the English to code, you can pretty much do anything, in terms of the business domain, right? So, okay, so this is the way, okay? Again, this is the way. You guys are losing steam. Yeah, this is the way, okay? So the best way to use generative AI is to leverage the generative nature of it. What that means is that in use cases that are not prescriptable, not pre-programmable, they're generated at the moment, okay? So this is the Bulgarian Academy of Science, right? So I wanted to focus a little bit more on the science aspect of it, to even go deeper. Now you know how it works, where it could be work, right? I want to go a little bit deeper to understand why it works. As a scientist, it's always important to understand why it works, because if you know why it works, you will also know the potential and limitation of these tools, okay? So the reason why this generative AI works so well is because something called high intradimensional correlation. So I just told you what it is, okay? So those of you who know what that means will know what that means. Those of you who don't know what that means, you have no idea what that means. So I'm going to show you what that means, okay? So these high intradimensional correlation is very prominent in a visual image, in, say, an image. So this is actually an image of a place, okay? So I have masked out 99% of the pixels of this image. So you can't see what's underneath it. If you could see it, you're a genius, okay? I don't think you can, but if you can, okay, then let me know, okay? I'll be very curious to see how you can see underneath here. Okay, so now as I slowly reveal more and more pixels, 97% mask, right? At some point, you will start to be able to see, what's underneath it, okay? So for example, okay, so this clicker is getting, so at 90%, right, you can kind of see a little bit of what's underneath this, right? Okay, what that means is that you're able to fill in those black pixels. You could fill those in. You could fill those in, right? Okay? Now, how about at 80%, okay? You could kind of start to see what this place is, right? And this is actually a place that I'm sure none of you have been to before. No one has been to this place, because this place doesn't exist. This is actually a generated image, okay? So none of you have been to this place before, so none of you have seen this image before, yet you could actually fill in those black pixels and see what the picture is behind it, okay? So at 60%, you could kind of do that very easily, right? You can kind of see that. You could fill in those black pixels. How about at 30%? Now it's very easy, right? Okay? Now, the reason you could do that is because every pixel is highly correlated to this neighboring pixel. By seeing one pixel, you could guess what the neighboring pixels are, okay? So if I ask you to fill in those black pixels, you could do that no problem. You do that in your head anyway. That's why you can see what the picture is behind it. Okay? Now, you won't get every pixel perfectly, right? So this is actually the image. This is actually a place. Who has been here before? I don't believe you. It doesn't exist, right? So, right? So, okay. So if I ask you to fill in those black pixels, you will not get every pixel perfectly, right? You will not get every splash of the water, every burr, or every kind of ripple, or every crack of a statue perfectly. But you will probably get one image that looks just like this. If I show you one image after another, you probably cannot tell any difference visually, indistinguishable from this image, okay? You probably can't tell. So these type of correlation also happen in audio data as well. Any people work with music here, music technology? So this is what audio data look like, okay? So make sure the music is on. Right? So each one of these stripe is actually a musical tune, okay? So that's what audio data look like. These are called spectrograms, okay? So if you look at something a little more complicated like this, you know, turn this a little bit louder. It's actually 100%. Can we turn this a little bit louder? Yeah. A little. Okay. All right. So, okay. So you get the idea. You've seen some of these audio data, right? So let's try one more. Let's try one more here, right? So this is, you know, simple musical tune, orchestral kind of mini instrument, right? So this is actually another type of audio data. It's slightly different. This one's a little bit harder.
And the only way to be truly satisfied is to do what you believe is great work. And the only way to do great work is to love what you do. If you haven't found it yet, keep looking and don't settle.
Right. So this is a famous speech by the late Steve Jobs, okay? So that's what audio data look like, okay? So now I could do the same experiment with you, okay? So I have another audio data here, which I mask out 80% of the time sample, okay? Now, you have seen a few examples of audio data, right? If I ask you to fill in those black stripes time samples, you probably cannot do it at 80%, right? It's pretty hard. But at 70%, nah, not quite, right? Right? How about at 50%? You could kind of start to see some pattern here, right? You could kind of start to see some, almost fill it in. You could almost see what the pattern behind those black stripes are, right? How about at 30%? You could definitely do it. Right? At 30%, you could definitely, if I ask you to fill in those black stripes, you will have no problem doing that, right? And like I said, you will not get every one of this, you know, correctly, every tune, every timing, perfectly. But if I actually play the music, you know, you probably will sound auditorily indistinguishable from this.
Oppan Gangnam Style. Oppan Gangnam Style.
Right? So, okay? Now, let's come back to the text domain again, okay? So this is, again, you know, ChatGPT basically wrote me a poem when I turned 50. So I am, you know, more than half a century old, so I look younger than I look, but I'm actually pretty old. But so I have randomly masked out 10% of the text here, okay? So if I ask you to fill in those words that's masked out, you also will have no problem doing that, okay? And like I said, you will not get every word perfectly, and that's okay. You probably get one that's semantically indistinguishable from this, okay? You probably get like, say, you know, your passion for learning and innovation here. If you could replace it by love or, you know, many, many were possible, right? Semantically, indistinguishable, right? Okay? Now, this is actually how generative AI is able to generate photographs that won awards, right? It's able to generate art that win competitions. It's able to basically, you know, in the musical domain, right? You know, these generative AI can already deepfake famous artist's voice, right? Wire basically says that AI-generated music is going to flood the streaming platform. Got the people on the hill worry. In the future, it may even win an Emmy Award. Okay? It may even win an Emmy Award. So now, do you believe that? Okay, if you don't believe that, I want you to hear this piece right here. This is an 80-second of a AI-generated music. So I want to turn this music up a little bit. Still performed by human. What do you think? That's pretty amazing, isn't it? Right? Okay? So again, it's all done with the same technology. Given a sequence of tunes, what's the next most likely tune? Right? And you do that for one instrument after another, and you time synchronize them, you get this. Amazing, right? Okay, so this is the way, okay? This is the way. Yep, correlated data, right? It's actually what enabled generative AI to create these music, artworks, photographs, right? Or anything you want to generate. Because by seeing a few like words, or few pixels, or few tune, you could generate the rest of it very, very reliably. You could even do that in your head. So generative AI could do that also, okay? So with that, I'm finished for the first part, okay? So this is my LinkedIn QR code, so you could connect with me if you want the, get the slides or whatever, okay? So next part, we'll try to answer this question, right? So the first part, hopefully you guys have some fun, okay? You guys learn something? Okay, you have fun? Okay, if you have fun, good, you'll remember it, okay? You'll remember it. Okay, so next part, we're gonna get a little more serious, okay? Because we're gonna answer the question of what's the ROI of your generative AI, okay? And, okay, so with that, let's take a short break and we'll come, I don't know, how much time do we have? 15 minutes. Okay, so 15 minutes, let's come back here. Thank you. Yes.
It's nice to meet you. You can go back to where your work
Thank you. All right. So let's get started again. And before I start the second part of the lecture, let me ask, are there any dying questions people want to ask? I think there are mics up here, or is there anybody who want to ask me something, or before I go on?
Maybe after this lecture, we will have a panel for...
Okay, all right, okay. All right, then let's start the next part. So that is my QR code. A lot of people are asking, ask me for the slide. Just connect with me, just connect, using connect, don't follow. If you connect with me, then you can send me a message. Then just send me a message, tell me that you are in this lecture, because I'm giving a lot of different lectures somewhere else as well. So tell me in this lecture, and because the lectures are actually different. They're not exactly the same. So. Excellent. Yeah. So just message me. Yeah. Okay. Okay. So So the second part is going to be a little more serious. Okay. We're talking about business here, real business. Okay. So the question that we need to answer is, now you've seen how amazing this generative AI is. What is the ROI? If you are in business, whenever there's a new technology comes up, you always say, what's the ROI? Okay. I think for this part, I think it's okay to leave the lights on. This one, the lights is okay. Yeah. Yeah. Okay. Yeah. Good. It's all good. Yeah. So yeah, the last part has some part that's pretty dark, and I think it's better with a little dim. But this one is okay. So when there's a new technology, people always will ask, what's the ROI? And from what you see, what can you tell me about the ROI of generative AI? Well, what do you think it is? Well, basically, it's some kind of productivity gain, right? You could do the same thing that you do before, but a lot faster, right? You could reply your email. It may take you like an hour to reply 50 email, but now you take you 10 minutes or something like that. It may take you, hours to do some design, graphic design. Now you could do it in 2-3 minutes, right? So huge productivity gain, right? As the example I give you, even with in the pharmaceutical industry, they could screen and screen through and evaluate thousands of candidates for drugs, right? In a matter of hours, something. So huge productivity gain. So in terms of business ROI, it's always some kind of efficiency improvement or productivity gain. Now, the question that a lot of people often ask is well, can I use it to kind of drive profitable growth? Can I use it to help run my business more profitably, right? This requires some true intelligence, human intelligence, right? So, right? So this generative AI seems so amazing, right? But it seems that all the mechanism for ROI is productivity and efficiency gain, right? So it turns out that you can actually go to this website called There's AI for That. Okay, it tries to catalog all kinds of AI tools out there, and this is actually is not the most current, but there's actually tens or almost probably hundreds of thousands of different AI that's been created already. Okay. And surprisingly, if you actually browse through this catalog of all the AI that was created, there's actually not that many that are used for business decisioning, especially in mission-critical decisioning, okay? There's not very many of them. And why do you think that's the case? Why do you think that's the case? I mean, the reason is really most of the mission-critical business decisions are not made with the help of some images or some, or some music or some movie or something like that, right? Most of the mission-critical business decisions are made with the support of some sort of structure, tabular data, okay? So tabular data is actually very different from the data that generative AI work with. They are, there's some properties of tabular data. So tabular data look like this, okay? So this is what tabular data look like, all right? So this is actually, in our pricing domain, right? So this is actually the transaction data. So these are the first row here is the transaction ID. The second one is the date of transaction and the week of the transaction. The rest of it is some attribute of the product, of the customer, and so on, right? So they look like this, and they look very complicated. So one of the properties of tabular data is that they have typically lower dimensionality than images and videos and audios, okay? And text as well. So that makes it easier, right, to work with in terms of computation. But what makes this data impossible to work with generative AI is the fact that there's a lack of this internal correlation, right? Okay? There's almost no correlation, right? I could do the same experiment with you. You already seen this picture. You already seen this data. You looked at it. Stare at it right now. Look at it, okay? Let's do the same experiment with you again. I mask out 20% of the data element here. And if I want you to predict what's behind those black pixels, now it becomes very difficult, right? Let's focus on just one of these elements. Let's look at that particular element right here, okay? All right? So as I reveal more, I say now it's only 10% mask. Can you guess what is actually behind that blackout kind of data element? Can you guess what that is? Right? And as I reveal more and more pixel, it doesn't seem to help you, right? So the reason is because there is no correlation. So you can't leverage your visual system, your brain, to fill those in, right? So even if you squint on it, it's actually very hard. I see some people kind of squint on it like with your eyes. It's very hard, right? So now I actually pick a really easy example for you guys. If you look at this row right here, right? Looks like there's only two values. There's only blue and red. So it comes down to a guess, right? How many people are saying it's going to be blue? How many people are saying it's going to be red? It's about half. It's almost 50% between all of you, okay? So 50% says, okay? So, and I reveal like now 3% at 1%, right? Last chance, who think it's blue and you want to change your mind, okay? All right, this is actually red, okay? So, right? Now, the key thing is that it's actually not easy for you to figure that out, right? You almost randomly guess that, right? So, because those correlation doesn't exist. You can't leverage those correlation, right? And a lot of the most important mission-critical business decisions are typically made with these type of data, okay? That's why generative AI cannot help you, right? When you're dealing with this type of data, right? Okay, so let's kind of switch gear a little bit and just look at the problem from the other way around, okay? What does it take to drive profitable growth? What does it take to drive profitable growth? I mean, if you actually, look at the profit equation, it's actually very simple, right? Profit is equal to revenue minus cost, right? So really the key is that you need both of these terms. You need to be able to manage both of these terms. So with revenue, you want to optimize it. With cost, you want to estimate it accurately, right? So let's look at the cost side. So the cost side of the equation, right? If this is your actual cost, right? You want to estimate that cost very, very accurately, as close to that as possible, right? Now, if you estimate that too low, what will happen? What will happen when you estimate a cost that's too low? That's something really bad, okay? If you estimate a cost is too low, you could actually sell below the actual cost, right? And that actually give you negative margin, you're losing money. It's actually really bad for business, right? So what happens if your estimate is too high? What happens if your estimate of cost is too high? Yeah, no one's going to buy it, right? So one thing is that, like, if that's the market price, right, and your estimate is too high, you'll be selling above the market price, so you lose competitiveness. Nobody will buy your product at that price, right? And the other thing is that, like, you would probably, if you think that is the cost, right, you probably turn down a lot of deals that contribute positively to your business, right? So all of these green, right, deals, right, they're actually above the actual cost. Right? But if you think the cost is here, you probably would turn this away, right? You're probably not going to sell it, because, so you actually turn away real business opportunity that contribute positively to your margin, okay? So you want an accurate estimate now. And a lot of business will tell you that I know what the cost is. I know what the cost. For example, like if I want a cost for this table, I bought this table. I know what the cost is. But the thing is that in a market that's not volatile, that's okay, Because you bought this table, you pay for it maybe, 2 years ago or 3 years ago or 10 years ago, something like that, right? That's what you pay. That's not the cost now. The cost now may be very different. So in a highly volatile market, right, that cost is going to change from day to day, right? If this table was in a cargo ship in the Red Sea that gets, bombed, right? Because, it's not going to be the same price every day, right? The price is going to change dramatically, right? So accurate costs, right? The material cost, what you pay for it is what the cost back then when you pay for it, right? In a non-volatile market, you could assume that to be the same. Right? But in a volatile market, you cannot assume that to be the same, right? So you need accurate cost estimate right now, right? And many product and services are actually not directly linked to production, right? So some industries are actually with what we call supply constraint, such as travel, transportation. So these are industries where we have essentially services or goods that are perishable, right? They're actually, after the plane take off, right? That seat is no longer worth anything. Right, so these are industry with a supply constraint, and there's only a fixed number of seats, right? So you need to, for these industry, you can actually use opportunity cost as a cost, right? So opportunity cost is a cost incurred by selling something right now at this moment. So that's the best estimate of the cost, because by selling it right now, you can't sell it later because there's only one of that thing, right? If there's a supply constraint, right, then that's what happened, okay? All right, so this is the cost. It's actually the cost based on the current market demand for your, in the current business environment, okay? So that's the cost side. We know we want to accurate that as accurately as possible right now. Right now meaning that at the time of the transaction, when the transaction is being made. Okay, not right now when we speak, not right now when we agree on the deal, right? At the time of the transaction is being made, okay? So what about revenue? Revenue, of course, every company tries to maximize that revenue, okay? But a lot of things could maximize the revenue, right? You can have a better, more efficient sales team, that would boost your revenue, right? You can even do better marketing that will actually help you boost your revenue. You can even build better product, and that will also help you build revenue. But the thing is that each one of these is actually further and further upstream. Further and further upstream. What it means is like the impact on the actual revenue is less and less. Okay? So marketing has less direct impact on revenue than sales, right? And product has, less direct impact on revenue than marketing and sales. They're further and further upstream, right? So turns out that, the pricing actually is the most direct driver for revenue, okay? In fact, there's a famous Harvard Business School study that shows you that 1% change in pricing, right, can drive up to 11% margin improvement. Huge, okay, margin improvement. In fact, they have demonstrated that 1% change in price has more impact on revenue than 1% change in anything that you could do in a company. 1% change in pricing, right, has more impact than 1% cost saving, 1% efficiency gain, 1% headcount improve, headcount, more headcount, 1% anything that you do in a company, right? 1% pricing has more impact on that, on revenue, than any of those, okay? So pricing, because pricing is the most direct driver for revenue, right? Before you can sell anything, you need a price. If you don't have a price, you can't sell, right? You need a price in order to sell. So the best way to maximize the revenue is actually optimize the price, to find the price that actually give you the maximum revenue, right? So that's what you need. So now there is an industry that's notoriously kind of in the sense that they are constantly under pressures from the margin. Okay, so commercial airlines actually have always operated under a very, very thin margin. Anybody know? Anybody here fly? Everybody flies here, right? Have flown somewhere. You have taken a plane before. How much margin do you think the airline make on average? Any guess? 10? Okay. Lower, okay? Before COVID, it's about 5%, right? About 4 to 5% on average. Low-cost airline actually makes a little bit more, okay? Low-cost airline, because the lower the cost, so much the margin is a little bit bigger. But on average, 4 to 5%. Actually, last year, after COVID, it's actually 2.5, 2.6, 2.7. Actually, recently, it's only come back to 2.6. They projected next year to go back to 2.7. Very, very thin margin, okay? So airlines have to use, essentially machine or AI to help them make decisions all the time, right? If they don't, they're in trouble, right? That's why airlines have developed something called the revenue management to help them manage their revenue, okay? So let's take a look at how this works, okay? Conventional revenue management, is a way to control what the fair price that a consumer actually see. Now, airline is actually also a very difficult business. Not only their margin is very, very thin, they're also highly regulated, okay? They're regulated in the sense that they have to publish all their fares, okay? They have to publish all their fares out there, okay? So how do you achieve, profitability when you have so much, regulations, so much restriction, right? So airline use something called revenue management. So this is something that, you can actually use for when you buy your ticket next time, So revenue management, you forecast the future demand for your flight, okay? And then no forecast is ever perfect, so they actually have a human kind of a demand analyst to influence those demand, and they optimize it. And then what you get out from this optimization is what we call a bid price vector. And that bid price vector represents the marginal opportunity cost for selling that seat. So the opportunity cost for selling that seat right now, okay? If you sell that seat right now, right, the marginal opportunity cost, say like, so it's actually 30 days prior, just means the days before the plane takes off, okay? So 30 days before the plane takes off, you have 25 seats left, the bid price is $295. So 295 is the marginal opportunity cost for that seat, okay? So if you sell it at 295, right, you break even, right? Because in the future, opportunity cost is what you could have gotten otherwise, right? People know what that means, opportunity cost, right? You have basic economics, right? Okay? So what you have gotten otherwise. But you should never sell anything less than 295, right? Because if you sell it for less than 295, then you could have gotten it if you don't sell it, right? You could have gotten it so you could have gotten 295 otherwise. So you should never sell a seat less than 295. So what they do is that, like, even though the airline have to publish all their fares, right? They publish all their fare classes. What they do is that they could dynamically open and close different fares, right? They say, okay, if my bid price is 295, I just close everything under 295, right? Anything less than 295, I don't want to offer that, right? So now the consumer basically sees a fare that's open, that's $300, and they could decide whether to buy or not, right? And then basically that actually comes, whether they decide to buy or not becomes a feedback information that updates the forecast to allow the airline to forecast the demand for those routes. Okay, so that's how they actually do that. Okay, so now this is actually, this system right here is conventional revenue management, is automating the generation of bid price, and it's also learning, right? It's learning, right, through the updated kind of market uptakes, right? Whether people are actually buying or not from the market, right? So this is actually a classic definition for AI, right? The definition of AI, the way I define it is that AI is really a machine mimicry of certain aspects of human behavior with two important characteristics. One is that it has to be able to automate human decision or action, okay? So it has to have that, and it has to be able to learn, okay? Learning means that it has to be able to improve its decision, its ability in performing what it's actually doing, the decision it's making. Okay, so you have to make better decision the more you use it, okay? So there are lots of systems that learns but don't automate anything. There are also lots of systems that automate a lot, such as a factory assembly line, right? But they don't learn, right? So neither of those are AI. But if you have both of these criteria, then you're an AI, right? And if you actually look at this system, right, it's automating the generation of bid price, and it's actually learning and improving to give you a better bid price based on what the market react, right? So that's actually a rudimentary AI system there, okay? So now you can basically look at this a little bit deeper. This is actually what we call model-based reinforcement learning, right? So it's based on a known mechanism plus the data and statistic. How does that relate to the reinforcement learning that we heard about today? The only difference is that you replace this known mechanism. This is a known mechanism, right? The known mechanism, right, with essentially a black box. You replace it with a black box with a deep neural network. That's what we call a model-free reinforcement learning. And that's what a lot of people refer to today as reinforcement learning is this, okay? Whereas the model-based is also a kind of reinforcement learning, okay? So now what's the advantage of having a model-based versus a model-free? What's the advantage? I mean, the biggest advantage of being model-free is the fact that it's general. It's generality, okay? It's actually very highly flexible. You could use a neural network to build this, to model this entire process. You could use a neural network to build ChatGPT or any other generative AI, okay? Same neural network, okay? Maybe a little bit slightly different architecture, right? So it's generality, it's the biggest advantage there. But what's the advantage of a model-based reinforcement learning? It's the fact that, you know the mechanism, right? You know the mechanism, so you can actually interpret it. You can actually know what it's actually doing, right? So this, like I said, you replace this whole mechanism with a black box, and the black box is something that you cannot interpret. You cannot make sense of what it's actually doing, right? So you lose all that transparency. You cannot interpret it anymore, right? So coming with this transparency is the ability to manipulate it. If there's some forecast that I know is actually not perfect, you can actually correct it, right? But if you have a black box here and the result is not what you want, there's no way for you to fix it, right? You don't even know how each one of the parameters contribute to the output, right? So there's no way for you to actually change it, right? So also the model-based reinforcement learning is actually a lot more data efficient because you know the mechanism. Every piece data that you use is used to determine the input and output. The mechanism is fixed, right? When you have a model-free approach, right? Model-free approach, a lot of those data is actually used to learn how the mechanism works. You need to learn how this actually, the input translates to the output, okay? Okay, all right. So now with this revenue management, I can essentially get the right price in front of the customer at the right time, right? But one of the big questions of revenue management is like, well, if I don't consider the customer's willingness to pay, right? You can't really get the right price in front of them, right? What if this customer's willingness to pay, he's only willing to pay $250 for the seat? and you offer him a $300 fare, you're going to lose this customer. You're going to lose this customer, right? So you can't really have the right price without considering a person's willingness to pay, right? Every one of us have different willingness to pay for something, right? Some people are willing to pay $500 for a meal because they're foodie, they like to eat, right? Some people like to, fly comfortably because whatever reason their willingness to pay for a flight, for a seat on the plane is higher, right? So different. You have to consider what the willingness to pay of a customer is. So how do you do that? How do you actually get that in there? Now, so remember I told you about this bid price? The bid price actually represents what we call a low-end control. It tells you at what price you should never sell the fare for because you'll be losing money, right? Because that tells you the opportunity cost, right? So it's an entry point, right? So it tells you should never sell it lower than whatever that bid price is. So this bid price is actually very good under what we call normal operation. But when there's, for example, a demand shock, such as during COVID, what happened? Nobody flies, right? So that's a demand shock. The demand dropped precipitously, right? Demand completely dropped, right? So why is this bid price not effective during demand shock? Think about this opportunity cost. Right? During COVID, what happened if I save a seat and don't sell it today? If it was COVID, how much can I get for that seat in the future? Nothing, because still nobody's going to fly, right? So the opportunity cost is zero. So telling the airline that you should never sell a seat lower than $0 is not useful information, right? They already know that, right? It's not useful. So what you need is, the excess capacity basically drive this opportunity cost down to zero, right? So what you need is what we call the willingness to pay, right? Even though your bid price tells that, okay, you should never sell it below zero, but it doesn't tell you how high you could sell it for, right? You could sell it as high as a person's willingness to pay for that seat is, right? So as long as you're willing to pay, right, that's how high you should set the price, right? So now, when you actually have inputs to this, so these are the typical inputs to your revenue management system. Seasonality, holidays, event, and availability, meaning how many seats remaining, right? You need to know how many capacity that you have. And you also need the booking, right? These are the current booking already, people already book your flight, right? So you also need the price. So to get that willingness to pay information into this revenue management system, you basically need what we call this willingness to pay model, right? So one way to model people's willingness to pay is just using a very simple exponential demand response model, right? As price increase, people's demand for that drop, right? People don't want to pay such a high price, right? If price is low, then the demand is higher. So demand is essentially a proxy to booking. So that's why I use B for this, okay? So this exponential demand model actually has this form, has this lambda and this exponential minus the price, divided by a parameter called alpha. So that's simple exponential curve. You guys are supposed to be very good with math here, so. Okay, all right. So from your basic economics, you know that these little rectangle represents the revenue, right? When you have a price multiplied by the demand, the number of booking that you have, you get your revenue, right? So your revenue is essentially equal to B times whatever the price is. So what happened what if I want the profit margin? What would I need to do to get the profit margin? I would need the cost, right? The margin would be the demand times the price minus the cost, right? The problem is, how do you get that cost? How do you get the cost? Remember, I had the bid price, right? And that is opportunity cost. And that's actually a very good estimate of the cost at the moment when the consumer wants to buy that seat, okay? because that actually tells you the opportunity cost if you don't sell it and what you would have gotten for that seat in the future, based on future demand, for that seat, okay? So now, basically, if I want to maximize this margin, what do I do? Remember your calculus? Who here have calculus before? Hey, nobody remember calculus? Dude, you know, you take the derivative of your margin and set it equal to 0, right? That's your basic calculus, right? You want to maximize anything, you take the derivative and you set it to 0. So basically, you take the derivative of the margin, basically, so that's derivative of the, so this booking is right here, right? It says precisely this exponential form, right, times the price minus the cost. So it's a product. Derivative of a product, you use a product rule. Anybody remember the product rule? Nobody. Come on. Okay. Alex, you could tell me what the product rule is, right? Right? So, okay, basically it's first times derivative of the second is the derivative of this constant term, which is 1, plus second times derivative of first. Derivative of first is derivative of the exponent, right? Derivative of the exponent is actually it's the exponent itself times derivative of the inside, which is actually just minus 1 over alpha here. Remember your calculus? This is a good review. It's actually very useful, okay? All right. Now it just comes down to solving this equation. If you solve this equation, right, you know the exponential actually is never 0, right? And you solve this equation, you basically get this alpha equals P minus C. And then, so the optimal price is this cost, the opportunity cost, which is a bid price, plus this alpha parameter. Isn't that amazing? To a math guy like me, this is just as amazing as hearing that beautiful piece of music that you heard before, okay? So you could call me a geek. I am, so, okay. So basically you have this bid price here, right? This is the cost, which we call this the cost, right? And if I have an estimate of the alpha, then I would know what the optimal price is. That's the price I can set to make sure that I get the highest revenue possible. Well, that's when the revenue is maximized, right? Because I took the derivative and set it to 0. That's how you maximize anything, right? Okay? So the question is, how do you get alpha? How do you get alpha? Right? I show you, if you have alpha, that's what I need to do. Just add it to the bid price. The bid price I can get from your traditional revenue management, which every airline has, okay? A lot of other business also have some systems similar to that, but every airline has some revenue management system. And how do you get the alpha? Okay, so that's actually done through what we call a double debiased neural network-based robust estimation. So mouthful, but really means it's a two-stage semi-parametric model. You use a deep neural network to predict the booking and the price, right? And you could plot the booking and the price, right, together, and you get some curve like this. And then the second stage, you basically estimate of how do you essentially fit this curve, right? And then once you fit this curve, you get the alpha, right? Once you fit that curve, you get the alpha, right? When you then you basically you can actually take whatever bid price that you get from your revenue management system, and then just add that to alpha, and then you're done, all right? And because the first stage is a neural network, it's very flexible. You can actually add any kind of additional predictor that you want, right? You can actually, for example, at the time of the transaction was made, you can actually get information such as competitor fare, what people are actually searching for, right? What events are actually happening at that time, right? So people's loyalty status and the weather and the economic, you can actually put in a whole bunch of predictor to help you estimate a better alpha, right? And better alpha just means that you capture more revenue, okay? Okay, so this is actually very interesting because airline actually gets more revenue, but the customer actually get a better and more personalized experience because the willingness to pay is matched to their willingness to pay, okay? So everybody's happy. The customer's happy, the airline's happy, okay? So it's an airline's way of achieving personalization, okay? So now, airlines actually have a long history, for estimate the opportunity cost, estimate the opportunity cost of their seats using revenue management, right? And they basically use this forecast and optimize approach. Now, this actually inspires a revenue management solution for lots of other business that may not be an airline, right? To be an airline, you have to have a lot of data to actually execute this revenue management practice. Okay, so now, why is it difficult to actually implement revenue management in most companies? Because forecasting is actually very hard. Forecasting is actually very, very hard. Okay, even today with all the advancement in AI, we can't forecast everything far out. But with airlines, they have to estimate something very far out, a year from now, for example, right? Because today, if you go to any of your favorite airlines today, you can actually buy a ticket that departs a year from today. What does that mean? It has to be able to estimate the demand a year from now and an estimate of the opportunity cost of their seats a year from now. That's something very, very difficult. An airline is actually doing that. That's why they're able to offer you a price for that seat, okay? So it's not easy. But so forecasting is very, so for the reason the airline is able to do it is because actually people's travel behavior is actually fairly predictable, okay? But for other industry, demand is highly volatile. For example, in cargo or maybe rental or stuff like that, the demand actually comes like very late. When the plane's about to depart, then all of the cargo demand comes in the last couple of weeks, right? And that's not enough for them to forecast a year out. The reason that we airlines are able to forecast a year out is because people plan a year out, okay? We buy and book tickets a year now. We change them, sometimes, but lots of other industries don't have that benefit, okay? And also, lots of other industries, they don't have this historical data to help them do this forecasting because they don't keep them. They never had a revenue management practice in their company, so they never have those data, okay? So when you don't have these, basically, revenue management is something very hard, right? So basically, we try to address this problem, say, can we actually just use a booking to predict what the bid price would be, okay? And we basically created this algorithm called Diane, okay? It's direct, that means you get the bid price directly from transaction, and it's adaptive, and we use a neural network. Basically, use a neural network directly to predict what the bid price is, okay? So, and the interesting thing is there's no forecasting anymore because you directly predict what the bid price is, okay? And because there's no optimization, you don't have to have such a heavy, I would say, cost when it comes to implementation because you have to pay for the optimizer, right? And it's also flexible to incorporate additional data sources as well. So the real test is does that work? Does it actually work? Okay, so we actually did a POC with the Asian air cargo carrier and the European air cargo carrier. So the first step, the prediction part, right? Both of these have an improvement. These are actually 19% kind of reduction in error. Okay, so it's actually MSE error reduction. So the error reduction is actually quite different, but in terms of the revenue that they lift, that they're able to provide, it's actually quite similar, okay? So this carrier is able to realize 3.2% revenue lift, whereas this one get 3%, okay? So what does that tell you? From this profit equation, if you are able to estimate this cost more accurately using essentially this opportunity cost, you can probably drive 3% revenue lift, okay? That's very significant, okay? So 3% revenue lift is actually very significant because it's actually direct revenue, okay? A lot of people say, oh, in marketing, you hear people say oh, I drive 70% conversion or 300% engagement, right? Those things barely move the needle. You have barely any impact on revenue. Less than fraction of a percent on revenue, okay? Driving 3% revenue is actually huge, very, very huge, right? Think about airline that have revenue on the billions. 3% is a lot of money, okay? A lot of money. Okay, so now pros also has a long heritage, and I think I've said that earlier, right? Pros actually have a long heritage in revenue management. And we can also help in this optimizing the revenue part, okay? Because from this forecast and optimization approach that we use for the airlines, we also develop another algorithm called Roxanne, okay? So that's actually for pricing. Remember I told you the best way to maximize revenue is to price optimally, right? So how do you find the optimal price, right? So that's with this Roxanne algorithm. So Roxanne actually is an acronym. It stands for Win Rate Optimized Explainable AI Using Neural Network. So it's a mouthful, right? But it really has, we know that it has two components. It has a forecast and optimize component to that. But before I go into the detail, let's take a look at how pricing is done before this type of algorithm. How do companies do pricing? You know, how do companies do pricing, okay? So traditionally, companies do pricing by segmentation, okay? So what they do is that they say, okay, these are the transactions, so there's a price, and this is some attribute, say like quantity or some customer attribute or something. And this look like they fall into three groups. And I'm just gonna divide them into three groups and take the average of each segment and call that the segment average as kind of the willingness to pay of that group. Okay, so that's a very rudimentary way of pricing, okay? And immediately you know that's highly inaccurate, right? Because the accuracy is terrible, because if you look at it, you know, this transaction and this transaction is like very close to each other. Why should this transaction get this segment price and this transaction get this one? Ridiculous, right? So it also doesn't support continuous attribute. Traditional pricing always requires you to bucket these things into some kind of bucket, right? So for example, if you have attributes such as a company's revenue, right? Company's revenue, it could be anything, right? It could be any number. You always have to bucket them into some bucket. Traditionally, people just bucket them into large, medium, and small company. And that's terrible, right? And later on, people have, you know, more fine-grained bucketing, right? They pick like, you know, 5, 8, 10, 15, but they have to bucket them. They cannot use whatever revenue that is. Right? At some point, they're going to say, okay, these are the companies that's larger than $5 billion, right? You may have a $5 billion company, and you have maybe a $50 billion company. They're hugely different. Why should they be in the same bucket, right? So, okay, and there's also limited, I would say, almost like no cross-segment learning, right? So these segments are separated, so the data is treated as complete isolation from each other, right? So in terms of a transaction, right, a company's willingness to pay, they may actually behave the same, but you will not know that at all because you separated the data completely already, okay? And the worst problem of the segmentation approach is data sparsity, because the more data that you have, the thinner you divide this data. The thinner you spread this data out, okay? For example, if I just have one more data attribute, such as the geographic region of my customer, okay? Basically, I would spread this data out so thin that each segment probably had only 1 or 2 transactions, right? And you know, from looking at 1 or 2 transactions, it's a very poor way to estimate the segment average, right? 1 or 2 transactions is like, sometimes you may not even get any transaction in some of those segments, okay? So now how does this, there's even more problem with this, right? One more problem is like, so some of these, so even though I get the segment average, right, which is the willingness to pay of that segment, that may not be the price I offer, right? Company may have used rules-driven price recommendation. They may say, okay, so these green ones, they already pay above the segment average. So let's let them continue to pay more, okay? And these ones that are pink, they pay below the segment average. So let's slowly get them up to pay the segment average. Let's slowly step them up, make them pay more, right? So these are rules, these are business rules. They are helpful, but there's no guarantee that they're optimal. There's no guarantee for optimality, okay? So, and there's also no trade-off information for price deviation. If you actually deviate from this segment average, forecast. So let's see how do we use this forecast and optimize approach to solve all this problem, right? So you take the same data, you basically feed it through this neural network again, you make it predict directly the willingness to pay based on all the attributes of the product, the customer, and the transaction. That's what you feed into it, okay? So looking at this, immediately you can see that there's improved accuracy, right? For those people who are math or data savvy, basically the segmentation approach is using what we call a piecewise constant function to fit your data. And you know piecewise constant function is a very bad model, right? It's good in something, but typically it's not very good, not very accurate. It's not even linear. Okay, piecewise linear is probably better than piecewise constant. Okay, but piecewise constant is actually very, very bad. Right, but now you get a smooth curve, much more, more accurate in terms of accuracy improvement. Right, and it allows for continuous attribute because neural network doesn't care. Neural network doesn't actually care what your input is. It could be a continuous value, or it could be categorical, it could be anything, right? And because you never divide the data up, right? You use the entire data set to fit this model, right? So you never run into this data sparsity problem, okay? And better yet, it allows for external predictors, okay? So now for the optimized part, right? So notice that using a neural network, we already address pretty much 4 major shortcomings of the segmentation approach, right? Now let's take a look at what the optimization does. Okay, so here to optimize, we're trying to optimize the win rate. So this x-axis here is basically the price. Okay, so it's actually expressed in multiples of a particular customer's willingness to pay. Okay, so it's in multiples of customer-specific price. Okay, so basically what that means is that at really high price, you're more likely to lose a customer. So this is a win rate. Okay, so this is a logistic function, very simple, kind of any probabilistic 2 class, right? Whether you win or lose, you can model with this logistics function, right? So at lower price, you're much more likely to win, right? At 0 price, you get the deal 100% pretty much. Okay, so that's what that is. Okay, so at 1x, right? You can see that this is actually the win rate is probably, say, it looks like it's like 70%, something right here. Okay, and now if you actually don't provide the identity of the customer to this neural network, right? It can still provide you a price, but because it doesn't know what this customer is, what you get out is the market price. Okay, and you have the cost information here. Remember I talked about estimating the cost using opportunity cost, right? You have that from previously, right? And you could put that in here. When you actually put that in here, you could basically get the margin by just taking the price, which is x, minus the cost, right? Multiplied by this win rate, right? Because that is the profit margin. That is the profit margin, right? The price minus the cost times the win probability. Okay, that is the cost. That is your margin. So you get a whole curve here. You get a whole entire green kind of margin or profit curve. Since you have the entire curve, now you can optimize it. Right? You can find the price. The target price is the price that maximizes this profit. And that's something that you could do very easily, right? You could use numerical optimization, and and now this price is from profit optimization, right? It's no longer rules driven. You know that is the optimal price for you to offer. There's no better price, a penny less or penny more, you're not optimal, okay? So better yet, you also can get the, if you say okay, so if you look at this, if I offer the optimal price right here, it looks like my win rate is, say, about 35% right here, right? The win rate. Okay? What if this is a customer I really want? And I'm willing to sacrifice a little bit of my revenue. Right? I don't want the maximum revenue. I want to get this customer because he's a very strategic customer, right? So you can actually say, okay, say I don't want the maximum right here. Let's take 99% of the maximum. Let's sacrifice 1% of my profit, right? Then basically, if I get this 1% down here, right, I could get up, if I charge this particular floor price right here, right, which is actually improve the win rate from what did I say, 35% to 75% here probably, right? So you can actually know what you're trading off, right? You can actually get this, if you deviate from the optimal price, you know exactly what you're trading off. How much revenue loss, right? You're gonna incur if you actually deviate from that optimal price, okay? So I want to say that this is actually the win rate. People who are in pricing, anybody here in pricing or do economics? Nobody in economics? All right, somebody, okay. So, right, so basically, a lot of people talk about this demand elasticity, right? So demand elasticity, it's actually very good when you do B2C pricing, consumer, mass consumer pricing, okay? Because when you increase price, the consumer demand drops, okay? That's what we did with the airlines, with their willingness to pay, the exponential demand curve, okay? But when you're actually doing B2B pricing, when you actually increase the price, you don't actually have lower demand. You just lose a deal, right? I mean, you know, and when you actually lower the price, you're not going to increase the demand, right? For example, if I need 100 of these table, right? What happens if I lower the price? The business still needs 100 table. I mean, you may buy 100, like maybe buy 5 more, but if you lower the price, you're not going to buy 200 because you only need 100, right? So when you're changing the price, you're changing the win probability. You're not changing the demand, okay? So the traditional pricing using this price demand elasticity doesn't really work for B2B pricing. Works really well for B2C with the airline case, but not for B2B case, okay? So now we have basically addressed all the challenges of segmentation pricing. All of it. But we also created a problem. Anybody know what problem we created? The problem is that we use a neural network, which is, again, a black box, right? You can't interpret it. So when you have a black box that tells you what the price is, right? How do you think the salespeople are going to adopt this? Right? Basically, a salesperson is going to say, I'm going to price you this clicker at, you know, say, I don't know, 20 euro, something like that. And your customer may say, for the past like 5 years, I always buy 15 euro. Why do you charge me 20 euro? And you tell them that my AI tells me to do so, right? Guess what the customer is going to do? They're going to say, forget you, I'm going to buy it from somebody else, right? So if you have a black box, people cannot interpret it, people have no trust in it, people are not going to adopt it, okay? So, but that's actually why we have this explainable AI here, okay? So this is win rate optimized using neural networks, right? We're using neural network and we optimize the win rate, but we also have explainable AI, right? So explainable AI actually allows us to look inside this black box and see what the neural network is actually doing. One way to do that is what we call the Shapley value. So Shapley value is basically a way to calculate the marginal contribution of each one of these features, right? So all this input that goes into the black box, the neural network, we just call them features, okay? They're essentially input, some attributes. And the Shapley value is the average marginal contribution of each one of these features, you know, over all the permutation subsets, okay? And why that is important. So this is actually a very complicated formula, okay? This is actually looks something like this. Probably not to some of the mathematicians here, right? Right? But it's actually what we call the fairest attribution, right? So the person who created the Shapley value, Lloyd Shapley, actually won the Nobel Prize in Economics for creating that, okay? So the intuition that I want you to get is like, you know that we need to get the contribution of each one of these features, right? But why do I need to average over all the permutation? The reason for doing that is because the importance of each feature is not the same in the presence of other feature, okay? Because, for example, a lot of people say competitor price is really important when I'm pricing something, right? Yes, it is. But when you actually have historical price, the competitor price is not as important anymore Because historically, you're not going to be priced way off of your competitor. You already have some idea. So in the presence of historical price, competitor price is actually not as important as it would be. Okay, so this is why you need to get all the permutation, right, of subset, because in the presence of other features, right, the contribution of one feature may be different when there are other features around. Okay, so but what you get out of this is what we call the price prediction waterfall, right? You would get a rank of how each feature, based on the Shapley value, how they're important. So if feature number 2 is the most important, feature number 3 is less important than that, number 6, and so on and so forth, right? But you will also get the contribution to this particular transaction, right? For this particular customer buying this particular product at this time, right? Say like X2 may be, say, the size of a company. So this may be it actually increases the willingness to pay because they're a huge company, they're a billion-dollar company. Maybe this is actually 3, maybe the geographic region. Maybe this is, oh, it's a big company, but it's actually in a developing country. So the willingness to pay actually drops a little bit, okay? So you get this price prediction waterfall that actually get the contribution of each one of these features, how they actually contribute to the final price that you offer to the customer. So now the salesperson can actually say, the reason I offer you this price is because, hey, you are a billion-dollar company, so I will increase your price a little more, but you are in a developing country, so I'm going to lower your price a little bit. So you can actually explain why you come to this decision. You know exactly why the neural network make that prediction, okay? Okay, so that's one type of explainable AI. So explainable AI is actually not an AI. It's basically tools that help you look inside the black box, that help you explain what the AI is actually doing, okay? So another kind of explainable AI that we provide is, for example, this, what we call comparable transaction. So comparable transaction is something that is very natural when you do segmentation. Like historically, remember, people always do segmentation pricing, right? So when you actually look at the transaction, looking at based on what their feature values are, right? And if you segment them, if you look at this particular transaction, and if you do segmentation before, right? For example, you may segment them like this. So these hard boundaries just said that, this transaction is in this segment. So the comps are basically, the comparable transaction are basically all here. And again, you know that that's very, very inaccurate because, these transactions here are a lot closer to this one than these guys are, right? So when you don't have segmentation, you basically take that same data, you just draw a sphere around it, right? So basically all these are the comparable transactions, similar transaction to this one. You could get 5, get 10, get 20. If you need more, just draw a bigger sphere. That's all, right? So, okay, so that's actually how you're able to look inside this black box and turn it into almost like a glass box, okay? All right, so does this actually work? Now this actually, we did, again, the POC in the US food manufacturer and the European-based global material distributor. So the first step, we talk about the accuracy improvement, right? The error reduction, about 20% here, about 50% here. So how do these better prediction of customers willing to pay translate to actual revenue? So this is it's a pity that these customers that we do this POC with choose to evaluate their kind of this algorithm using different metric, right? So this one actually uses essentially revenue lift metric. So this is actually 4.5% revenue lift. This one actually uses margin improvement. So 11% margin improvement, huge, okay, very huge. So we know that if we better estimate the cost, you could get about 3% revenue lift. By using this, more accurate kind of willingness to pay estimation, right, to predict this customers' willingness to pay using neural network, right, you can actually get 4% revenue lift or more. And together, that's 7% like profit, okay? Why would you give up 7% margin, that's like a lot of money, right? Imagine if you have again, billions of dollar revenue, right? 7% is actually huge, very, very huge, okay? So I talk a lot, I digress a little bit to talk about, take a look at this problem from the complete opposite side. But I'm going to come back and answer this question. Can generative AI drive profitable growth? Can it? Can it? Okay. Actually, not by itself. Okay. It's just like the case, you know, with generative AI with hallucination, right? You cannot use generative AI in a fact-based application alone. But you can use it if you couple it with, say, a search engine, right? If you couple it with a search engine using this retrieval augmented generation, you could use it in a fact-based application. Generative AI alone cannot drive profitable growth alone. It can drive profitability through essentially efficiency gain and productivity gain, right? You free up people's time so they can actually spend their time to do more revenue impacting tasks, right? But it's not a direct impact there, right? You're freeing up people's time so that they, you know, hopefully they will do something that drive revenue, but they could still not choose to do that drive revenue, right? So, but you cannot drive revenue growth or profitability alone, okay? So if you actually look at the type of generative AI that we have, right? Can we use generative AI in profit optimization, right? So generative AI such as ChatGPT is what we call a pre-trained model, right? So these are the data that we use to pre-train it, right? So in training, this pre-training actually takes quite a lot of time, right? So for OpenAI, it took them like 100 days, right, to train this GPT 3.5 to GPT 4. Okay, so this through engineering, this pre-training time can be shortened, but it can never go to zero. It can never go to zero. Can you see that, right? It always takes some time to train the ChatGPT, right, or to train any generative AI, because that's why they call pre-train, right? So now, the important thing to get out of this is that at the end of this pre-training, right, you get a model that has very, very broad knowledge, but everything is in the past. Everything that you know is in the past, that already existed, right? Okay. Now, what about the type of pros AI that I just told you about in the second path, right? Basically, all the willingness to pay estimation, all the forecast and optimization, right? All this is about now and the future, okay? But of course, pros AI is not going to have such a broad kind of knowledge, right? It's going to be very specific to a particular customer, to your specific company, right? So it's actually very, very complementary, right? So how can you use generative AI to drive profitable growth? You have to couple it with something, right? Just like in the case of retrieval augmented generation, you couple it with the search engine, right? So you can actually do the same thing here, right? You can actually predict and forecast the future using our technology, right? If you actually, and then give that future scenario to ChatGPT and have it summarized and give it to the user, right? And if your forecast accuracy drops below a certain kind of criteria, say whatever it may be, right? So if your forecast accuracy, if you're trying to forecast something that's very, very high stake, then the criteria will be very, very stringent, right? If your forecasting is for marketing or something like that, then may not be, you know, maybe 70, 80% is probably good enough, right? Then, if it falls below those, the criteria, the accuracy criteria, then you just tell the user, I'm not sure. Don't give it to ChatGPT. If you give it to ChatGPT, it's going to make things up again, right? So basically, I call this prediction augmented generation, okay? So PAG instead of RAG. So very similar to RAG, right? So because it's PAG, you know, you could also call it like pros augmented generation as well. So give pros a little bit plug here. So with that, you know, Yoda is going to say, this is the way. Because this is the way of the future, okay? Thank you very much. Yeah. Okay. Yeah, so are there any questions? No questions. Have I lost all of you? Oh, there's a question there. Can you come up? Yeah. Would you? Do we have to use the mic, or do we?
We can speak up.
Yeah. Okay.
Yeah, so your talk kind of focused on companies in a competitive environment, their profit margins, their costs. Obviously, the costs, especially like for stuff like airline companies, they are based on the price set by also other companies, and this is kind of core part of the model. Have you looked at essentially AI models that also look at collaboration between companies, and how could you model that?
I personally have not. Yeah, so it is a very interesting scenario. So airlines are highly competitive, but airlines actually one of the most collaborative industry also, because no airline can transport any passenger anywhere around the world. You have to collaborate with other airlines, right? For me to fly here, I can't fly here with the American airline, with United. I have to, they have to connect me, through another carrier, through Lufthansa to fly me here. So airlines are very interesting because they are highly competitive, but they're also highly cooperative, okay? I have not looked at using generative AI to model that, but my team and I have, during COVID, we did a COVID task force study where we actually look at we actually published a white paper called there's actually a positive sum game for the airline industry. So if you're interested, I could direct you to that.
Yeah, that would be great.
Okay.
Thank you very much.
Yeah. Any other questions? Yeah. I think there's also a mic there in the back, so you could. I think this is to benefit people who are watching online. And so we actually are live streaming this as well, so people could also hear. I think it's that one.
Okay. You explained that you have some specific mechanisms to look what happens in the black box in the second model. Have you compared what would happen if you directly try an explanation using ChatGPT without looking in the... Would it be plausible? Would it be close? Would it be very hallucinatory?
Yeah. I don't think it's actually going to be very good because, most people... there haven't been any, actually the only one, there's only a very few paper that actually been published about interpreting a neural network. Actually, one of them is done when I was in grad school. When we actually model the human brain, we actually published a paper on, using principal component to interpret the weights of the neural network. So there's actually not that much that's been published out there. So I don't think ChatGPT is going to be able to answer the question. If you give it a bunch of weights, bunch of neural network, and say, tell me what happened there, it's not going to tell you anything. I don't think so. You could try, but I don't think it's going to give you anything, okay? So, any other questions? Yeah. So.
Hallucination. Probably.
Yes.
Yeah.
Yeah, most likely it will tell you something, but you probably can't trust it because it's making things up. Because like I said, when there's no data out there, it's going to hallucinate, right? Because you didn't ground it, right? You did not find, anything that grounds the GPT model. Any other question?
Just to reiterate the point, basically what you just talked about, it was the elegancy of approach and the explainability. This is an essential part in any design. And what we discuss in any kind of model creation. But that's important to strike the note that neural networks are actually very sophisticated, very complicated, and that's why they're not really desirable, which is why, by the way, in some cases when you have to explain and convince a customer, is what the case was. Which is why, by the way, even Google that created all these great tools, they're still, for the majority, they're still using simple linear regression. Because it's easy to explain.
That's right. That's right. Yeah. Yeah. Just like, in segmentation-based pricing, right? People can explain that to customer. Oh, because you fall into this segment, so I price you this way, and these are the other similar customer like yours, then they all pay that much, so I have to price you that way, right? You can explain that, but it's highly inaccurate if you do segmentation approach, right? So how do you use you gain the accuracy of the neural network, but without losing, in terms of explainability? And we basically solve that problem by using neural network and using explainable AI. So, yes, yeah.
Talking about the accuracy, actually, it seems that your approach relies on the rationality of the customers. Rationality of the customers.
Rationality? Okay.
Of the customers, yes. That they usually use the whole information for their decisions. Based on this, I think you substitute the cost with the opportunity cost. In the context of the accuracy of the model, in reality, the customers are not usually rational. How this is situated in your theory?
Yeah, so like customer may not accept your explanation, right? I mean, you can always explain it and say like, this is why I priced this for you. But then if they don't, they don't like it, then go ahead and try. I mean, you could decide, right? You could decide whether this is a customer I really want and I'm willing to sacrifice some, because now you know the trade-off. Yeah, you know how much revenue you're giving up when you want to get this customer at a certain win rate, right? So you can actually make that decision. If you wanted to sacrifice a little bit of revenue or profit to get this customer, you can make that decision. But if you don't want to, you could tell them that, hey, go find another customer, find another vendor who could offer you a better price. Ask him to do it. Right? And he may actually go search around and eventually come back to you and say, you still offer the best price, So, with the quality of product that you have. So that happens, so you can make that judgment. So it becomes a negotiation, more like a game theoretic kind of approach there. Yeah. Any other questions? More? Okay. Yeah. I think there's a mic on the back that might be closer to you.
So apart from explainability, the other big problem of neural networks have been their robustness, right? Having spurious decisions that are incorrect, especially a little bit outside of their distribution. So have you looked at, also there is clear connections in the literature between explainability and robustness of neural networks, right? So have you looked into robustifying your classifiers and specifically on the data that you're looking at, do you see somehow improvements in generalizability to other data, to more customer real life data?
Yeah, robustness is actually very important for us. We actually do a lot of work there. It's kind of hidden on the back end. First, we regularize. So we do regularization to make sure that. So very often this spurious kind of prediction comes up when you have an under-constrained system. When you have a neural network that has too many parameters and you don't have enough data to constrain it, right? So you need additional regularization to constrain it so that you can actually give you a more robust output. So the other approach that we also leverage is using things that are kind of what we say, the robust loss function. So we don't use a square. Usually, when we do evaluation, we do mean square error. But sometimes we actually use L1, or we don't use L0. But we usually L1 does better when you actually use an L1 loss function. But the trade-off is that it's actually computationally a lot more heavy. So at that point, sometimes we actually said that the improvement you actually give us is not big enough for us to warrant to cost a lot more computation for that. So because in the business, sometimes the best answer may not be the one that you always implement, because sometimes it may be costly, right? So in that case, we actually did look at that, but it's actually, we decided that the accuracy improvement is good in terms of more robust, but probably not worth the computation involved. Yeah.
How about in terms of there is one case is about the efficiency when you implement it in production. Another thing is about also explaining it to the customer, right? So essentially, when you are able to demonstrate more robust results to your customer, this also leads to a better product and increased revenue, as you pointed out. So,
well, that's why we use explainable AI, right? Because the explainable AI, that's actually what give you the ability, right? We have two different kinds of explainable AI. Like I said, the Shapley value that explain how each feature contribute to the final recommended price. And we also have a comparable, right? I mean, and comparable transactions are something that salespeople have used a long time because they get that from segmentation, right? So they get, say, okay, these are the customers who are similar to you and they pay that much. So, you know, pay this, or you find someone else, right? So.
Yeah. Thank you very much.
Yeah, thank you. Any other question? All right. If no questions, then thank you again for your attention. So, yeah. I think we have some light lunch, right? So.
Ще се видим, отвън има обяд, така че ще поговорим малко на така неофициално между колеги, да направим малко нетворкинг, така да кажем. Заповядайте отвън. Благодаря.